start the session. Okay. So as you saw in the previous session, we started with our discussion with NumPy arrays, and we saw why NumPy is important and what is making it faster than the Python list and stuff like that. So I want to start this session by telling you some few key attributes about these NumPy and the arrays. The first attribute they have is shape. Okay, here I have mentioned that. That's the first attribute these NumPy arrays have. So shape, as I discussed that, for example, shape means basically the dimension. So if I make an array like this, so I have an array 1, 2, 3. Okay, so I know that this is just a vector. If I create a this is 1D array. So if I create a 2D array, 1, 2, 3, 4, 5, 6. So if I create this 2D array, so if I call the shape function on this array, let's name this array as A. Okay, so if I call A dot shape, so it will return me a tuple. A tuple will be returned in which the first dimension will be the first number will be the number of rows. That here we have 2 rows and 3 columns. That's what the shape is. Shape basically is an attribute of this array. Okay. So that's the first thing. We have n dimension array dot shape. Here I have mentioned it. Okay. So even there we have axes as well. For example, in the previous session we saw what is axis 0, what's axis 1. So there is this attribute n dimension. It'll indicate the now how many axes are there. Okay, 1, 2, 3 based on the array basically. Let's go to the coding window and see how the shape works. We'll just create a temporary array and see how the shape works, because in the coding setting you'll be using this shape attribute a lot of time. This is not a function, this is an attribute. So attribute means you don't have to call it like this. This is not right. You have to just call it dot shape. Okay, so let's go and check it in the coding window. I hope the coding window is visible. Okay, let's create an array here. Let's suppose ARR is equal to array numpy dot array. As we know that we can create an array like this. So let's suppose we create 2D array 1, 2, 3. This is auto switching the mode. So I created this 1, 2, 3, and this is a 1D array. So if I call array dot shape, okay, if I run it, so you can see on the, because we have to import NumPy, that's why it's giving the error that NumPy is not defined. So let's first import this. So import NumPy as NP. Okay, now let's run it. As you can see that it showed 3, 0, 3, nothing, because this is a tuple and it has 3 elements, as you can see in here. So let's create a 2D array now. 2D array means like array within an array. So first thing is I'll put one brace over here and one brace over here, and within the array I'll create and the array 4, 5 and 6. Now I know this is a 2D array. So this 2D array is of size 2 cross 3. So if I just run this cell, you can clearly see on here in the screen that the shape here is 2, 3. Okay, that's what I was mentioning here. This is what this shape does. Okay, then we have something called as size. Okay, size basically this represents total number of elements within the array. Okay, so if I want to check the size of the array, so I can just call the attribute size. So here you can see, I'll just go back to the coding window. I'll call array dot size now. So instead of the shape, I'll call dot size. So if I see the output, so that's 6, because we have 6 elements in here. Okay, size means how many. Is it visible? Oh, this is too big. Can you see it now? Is everybody able to see the screen? I think let me do one thing. Let me again switch the network. Just wait a second. Let me disconnect every other network. So here I disconnected this. Is the screen visible now? So how is it looking? Is it looking good now? Yes. Okay. So what I was saying is that this n-dimensional arrays, the arrays that we define in NumPy, so they have different attributes. The first attribute that we discuss is shape. Okay. So if I create an array and I want to know dimensions basically. So here when I create 2D array and I just call this array.shape in here. So when I called it, it gave me the answer as 2, 3 if you see it here. I hope this is visible now. Is it visible? Okay. So there is another attribute, size. So size means if you want to count the number of elements that are there in the array. So you can just write as size. So if I just execute the cell, you can clearly see that it is 6 because we have 6 elements in this array. 1, 2, 3, 4, 5, 6. Okay. Then we have D type. If you see again here on my tab, so here I have another attribute is D type. D type, you have to check what is the type of the elements that are there, because in the previous session we discussed that there can be different types of elements in an array, basically NumPy array. So if you want to check the type, so you can just call D type. So let's go to the code window and just type here D type. So D type. So you can see clearly that it is showing D type int 64. But what if I wrote some floating point numbers? 1.0. If I now check it, you can see float 64. Okay. Then we have something as item size. Okay. So this denotes basically the size in bytes for each element. So if we want to check it, so you can just write item size. So here you saw the result. Item size is 8. Basically each of these elements is taking 8 bytes. So just remember these basic attributes. So because when using the NumPy array, you will be frequently using these, because sometimes you want to check how many elements are there in the array. Sometimes you want to see what is the dimension of the array. So just keep these in mind. Ndim, shape, size, D type, item size, data. Okay. So two most heavily used things are this shape and size. Because I'll say I daily use them. For example, if I have a data and I want to see how many rows are there in the data, how many columns are in the data, I'll use shape. And sometimes I want to check, okay, how many total number of elements are there, I'll use this size. So that is these attributes of these ND array. There are other attributes as well. I actually told you in one of the sessions that there is a function dir by which you can check what are the attributes and what are the functions that are available for us. Is this clear? And there is a difference between attribute and a method. So that we will see when we will read about object-oriented programming. So just keep in mind that function calls are made by putting the braces like this. When you call an attribute, you just write dot shape. You don't give these braces. So when you give the braces, that basically means you are giving a function call. Is this clear? Okay. So now we'll see, like we have previously started how to create NumPy array. So in that we saw there are 6 methods, and I think we covered the first method. Like we can convert other data types in Python and use them as NumPy array. So we saw how a list can be converted, how a tuple can be converted by using a function known as np.array. Okay. We also start discussion of there are some intrinsic array functions. There are intrinsic array creation functions in NumPy. In that we want to create either 1D arrays or we want to create 2D, and we want otherwise create more than like 2D arrays greater than 2D, like 3D, 4D or 5D. So first function that we saw was this was, I think, in the first converting Python sequences. Then we went on this intrinsic in 1D, 2D and ND arrays. In the first ND and array creation, we saw the range function, a range function. It is similar to the range function that we saw in Python. Then we saw linspace as well. Okay, I think we covered till this part. Now we'll see how to create 2D arrays. Okay, there are some intrinsic functions by which you can create 2D arrays. First thing is, I like to define this identity matrix. How many of you know what is an identity matrix? Do you know identity matrix? Okay, so just for the for other people who might not know it, if you have a 2D matrix and all the diagonal elements are 1 and off diagonal elements are 0. So what are diagonal off diagonal elements? For example, I want to create 2 cross 2 matrix. So here I have 1, 1, 1 on the diagonal and rest of the entries are 0. So this is called an identity matrix, I2 basically, because it's of dimension 2 cross 2. Okay, so this is identity matrix. And if you see linear algebra, identity matrix are used a lot. and we'll use linear algebra for our machine learning algorithms. For example, if you see principal component analysis, we use this linear algebra in there, and main algorithm is linear algebra algorithm. So if you want to compute eigenvalues, eigenvectors, stuff like that, so basically these matrices are really important there. So what I'm saying is, if you want to create this identity a matrix, so there is a function called as np.i. Okay, so if I write np.i of 3, so what it will create? It will create a 3 cross 3 matrix. Sorry, this is a 3 cross 3 matrix here, sorry. So if it will create a 3 cross 3 matrix, which is an identity matrix. Okay, the output will be like this. If we go to the coding window and see, so you can see it here. So here, so if I run this cell, you can clearly see that we got an identity matrix of, for example, I want a 2 cross 2 matrix of identity matrix 2 cross 2. I'll just press 2, and you can see here we got a 2 cross 2 identity matrix. If I want 4 cross 4 identity matrix, just give input as 4, and I want to print it. So output here is 100. That's an identity of 4. The function is np.i. Okay. Then there is something called as diagonal matrix. Diagonal matrix. It is just like identity matrix, but the thing here is the diagonal elements are not one only. They may be the diagonal elements may have some other value. For example, if I have 1, 2, and 4 like this, then I have off diagonal elements are as zeros. So this is a 3 cross 3 matrix, but only diagonal elements have values. If you see it right here, so only diagonal elements have values, rest are zeros. So this is called a diagonal matrix. So where diagonal elements have or non-zeros, basically diagonal elements, they are non-zero elements. That's why it's called diagonal matrix. Diagonal elements, they are not zero. Rest are zero. Okay. So this is called a diagonal matrix. If you want to create a diagonal matrix, so for that NumPy gives us a function diag. Okay. So if you call this function with these values, so what will it do? It will just put these values as diagonal elements, and rest will be put as zero. So if you just see in the code, and here we have a function 1, 2, 3, diagonal 1, 2, 3. Okay. So if I want to print the first, so let's call it A, let's give it a name A, and I want to print this A. Print A. So output should be, it should be a diagonal matrix. So you can see that we got a diagonal matrix over here. 1, 2, 3. If I just change the value 1, 2, 3, 4, for example, so I'll get a diagonal element matrix of with diagonal values as 1, 2, 3, 4. So you can see that here. Okay. Then sometimes what we want is, sometimes we want that I should have a diagonal matrix, for example, like this. So I want to create a diagonal matrix where diagonal should be 1, 2, and 3. But what I want to do is, I want to just append some zeros. So for example, till here I want a diagonal matrix. This is 0, 0, 0, 0, 0, 0. But what I want one more row should be there and one more column should be there. So till here I should have a diagonal, and then we just wanted to append one row and one column here. So you can also achieve that by using the same function, diagonal matrix, diag. So but instead of just writing 1, 2, 3, you also have to write 1. This 1 will add basically these number of zeros and these number of zeros. So if you see in here, I'll just highlight them. So we added one row and one column here. Basically this is a 3 cross 3, a 4 cross 4 matrix, and this 3 cross 3 basically is a diagonal matrix. Till here it's a diagonal matrix. Okay. If I want to just run this function, so maybe I'll just go to the coding window and show you. So here I'll now call this as B. So I'll print B. Print this B. So as you can see, we got output as 1, 0, 0, and this is the diagonal element, diagonal, and we have one extra column in the front and one extra row at the end. If you know Gauss-Jordan method, and there these matrices are really useful. That's why sometimes we need to create matrix like this. So just have this in mind. We have something called as Gauss-Jordan elimination. So there is a method by which we find the inverses. So in that, these matrices are really important. So that's why we can create these arrays, these elements like this. You can also use directly an array to create diagonal elements. So I hope that now this diagonal, how this diagonal matrix is created, is sort of clear. Okay. Then we have something called as Vandermonde matrix as well. So there is a function Vander by which you can create these matrices. So these basically are useful in least square models. When we create machine learning models, basically there is something called as loss function. So most of the loss functions, sometimes we call them least square loss functions. So there it is used. Okay. So there are a lot of functions, and I need not to discuss all of these in detail. So there are a lot of functions like this. There are 40 plus functions, I'll say. I just wanted to show you that you have methods by which you can create them. So I have written down in the notes, and you can also do your own research by writing the documentation and see how to call these functions. The basic is np, then dot a function name, then you will have some attributes by which you will create that. So there are a lot of matrices. As far as I just showed here two examples. One example was this: how to create a diagonal matrix and how to create an identity matrix. Okay. Now you can also create any n-dimensional arrays. So here we saw how to create 1D arrays. Then we saw how to create 2D arrays. So we discussed two methods here, and we discussed some methods over here as well. Now there are some methods by which you can create ND arrays. For example, sometimes you want to create number of zeros. Let's just stick to 2D arrays as of now, but you can create ND arrays. So if you just want to create a zero matrix like this, so this matrix is 3 cross 3. So NumPy gives us a function np.zeros. So here it takes an argument as a tuple, which says how many, basically the shape, what is the shape of this. So if you call np.zeros and then give the shape, for example 2 comma 3, so it will create 2 rows and 3 columns. So this will be the output of this np.zeros. Then we have a function called as np.ones. Basically if you want a matrix in which all the entries are ones, so same thing, just instead of these zeros you can create np.ones, and then you can give the dimension that you want. Okay. Then I don't want to go into these default rings for this. Like there are functions like this in which you create random elements as well. Okay. Sometimes you want to create a random element. So I'll just go not over the ring elements, but what is meaning of what is these random elements. So there is a module in NumPy that's called random. So there is a random module. So if you want to sometimes initialize an array with a random element, so there are I think 4 methods which NumPy provides. The first method is random.rand. The first is rand. Okay. So for example, if you have this function np.rand random.rand 2 comma 2, so it will generate an array which has dimension is 2 cross 2. Okay. But what it will do, it will have elements between 0 and 1. Okay. So this is something called a uniform distribution. So we'll see that in probability. What is a uniform distribution? So here I want to tell you that if you want to create a random random matrix, let's suppose, and you want the elements to be in between 0 and 1 with a uniform distribution, so you can just call np.random. So this is NumPy basically is a library. So random is a module in it. .rand is a function. Okay. So if you sometimes, for example, want to go into the computers folder, you write, for example, home, and then you see local disk C, and then you go into the folder. It's similar to that. So this dot notation is similar to that. NumPy is basically a library. Then there is a module random, and in this random I have a function known as rand. So what this rand does is it will generate the numbers in the range of 0, 1. 0 inclusive and 1 is exclusive. 1 won't be. It will generate numbers in between that. Okay. Let's just see it in the action, and we'll see that. So here we have. So I have an np.random. I want to create a 2 cross 2 matrix. If I run it, you can see that I got values 0.3720, something like that. And if I want to create a 3 cross 2 matrix, okay, this is a 2D matrix. So you can see it here. If I want to create a 3D matrix, so I'll just put one more dimension over here. So I want to create 3 cross 2, 2. So you can just see this is a 3D matrix which has random values, and these random values lie in between 0, 1. Is that clear? Is it clear? Am I audible? Hello? I think I am not audible. Let me see. Am I audible? Hello? So I just checked my internet connection. What is stable? I couldn't hear the response from you people. Should I keep going like this, or should I ask for your response? Just see if I am not audible sometimes, because I have to check the internet as well. So I was telling you that if you want to create the random numbers, so you have these functions. First function is rand function. So then after we have a function known as rand_n. So what it does is it will just create numbers from the normal distribution. Okay, normal distribution looks like this. There is, in which we have a mean of 0 and variance of 1. So we'll discuss all these distribution in detail, but it will create numbers which have a mean of 0 and variance of 1. The function is rand_n. So for example, in here, if I want to create a 2 cross 2 matrix, so here I'll just give np.random.rand. Then I'll give the size. So here you can see that the output here is the 4 numbers which have the mean of 0 and variance of 1. Then we can also create random integers. Okay. So if I want to create random integers from some range to some range, okay, so that I can do is, for example, here I want to create numbers from range 0 to 10. I want 5 of these. So here you can see I created random integers like this in some range. Here 0 to 10, and there are 5 numbers. There are other functions like .choice which generate random numbers like given in 1D. So there are other random functions. So you can read about a random module, and there are, I think, more than 10 functions by which you can generate these random numbers. Okay, now I will move to the third method. Okay, so I covered the first method. First method was that by using the lists or by using tuples, you can create NumPy arrays. And the second thing is I can use some intrinsic NumPy methods, for example, np.zeros, np.ones, and things like that to create arrays. And the third thing is I can use the replicating, joining, or mutating existing arrays. If I have an existing array, and for that I want to create, and for existing arrays I want to create the new arrays, and I can either replicate them, I can either join them, and I can even mutate them. So for these things I can create arrays. Okay. Am I audible to the people? I don't. Okay. So Umar, are you there? I see very less people join today. Huh. So just respond to me, because sometimes I feel that internet is not working. So we are in the phase where we want to see how are these NumPy arrays created. So we are in that phase of the creation of these arrays. I showed you some methods, and now I will show what is the meaning of replicating, joining, and mutating the existing arrays that we have in NumPy. Okay. The first thing I want to discuss is what is a view and what is a copy in this. Okay, before going into how to replicate or how to mutate these, so I want to define what is a view and what is a copy. So for example, if I have an array like this array, I'll define it like this. So array 1, 2, 3, 4. So when I slice the array, or when I just index it, I write sometimes array of, let's suppose, 2 to 4. So this is 0, 1, 2, and 3. Let's say 2 to 3, let's suppose. So what will happen is it will just take this element 3. So this a new array, if I call it, let's suppose B. So this B will be equal to 2, just 2, because we are calling this. So this is not basically a copy. This is something called as a view. So view means there is no copy. It is just taking the elements out of these and creating a temporary view. So it is not having a separate array in the memory. Iska aisa nahi hai ki there is a new array. So new array does not get created. Instead, what happens is you will just have a view of the other array. Okay, basically both of these will share the same address. This ARR array and this B will share the same address. So it will just have one thing. So that is, this B will have like pointers from the here. So B will point to basically this element only, something like that. So this is view. But if you want to create a copy, so you have separate function called as copy. Okay, so there is a concept called a shallow copy and deep copy. Shallow copy means basically view, like loosely speaking. So shallow copy or view basically means you do not create a new array. You basically use the existing array and retrieve the elements from there. But copy basically means you want to create a new array, assigning that some memory. Okay. So now we want to see, for example, if we have this, that's why this, because we want to mutate these or replicate these arrays. So if I call np.array on this, and here this line of code will create an array. So we'll have an array of size 1, 2, 3, 4, 5, 6. So what we'll do is, if we write B like this, only this, without the copy. So what will happen is a new array will not get created. So what will happen here is this B array, it will be pointing basically to here, but it will take the values from 0. It will take the value from here to here. But this will not be the copy. This will just be a view. Okay, but if I explicitly want to make a copy, that is, I want to explicitly have a separate copy of this array. So what will happen is I'll just call .copy method. Then I'll replicate. I will have a separate array object. which will have 3, 4, 5, 6 values in it. Okay, so I'll have this separate array, and then I'll be calling it B. But if I do not have this copy method over here, then it will just be a view of another array, view of basically this array, A array. So is this clear? What is the difference between copy and a view? So copy basically means it is a separate array, and view means this is an array which is there already and we are just referring to that. So that's why we are here, how to replicate an array. If you want to replicate an array, you have to write a function dot copy. Okay, so here you can see that I have just like then added one, and you can see the effects here. So you can join the arrays. Okay, you can join two or multiple arrays if you want to concatenate existing arrays. Suppose I'll create arrays A and B. So here I see A is np.ones, that is array will be 1 1 1 1 because it's a 2 cross 2 array, this one. If I want to create an identity array, this array will be 1 1 0 0. So this is the call. And if I want to create an array of zeros, so it will be 0 0 0 0. Then a diagonal array, diagonal matrix, it will be -3 -4 0 0. So it will be like this. Okay, so now what I can do is there is a function called as block. Okay, so if I write np.block and write these arrays A, B, C and D, okay, if I write these things, so what will happen is first block, this is the first are A, this is our A, this is our B, this is our C and this is our D. So if you can see here, so this is our A, so then I wrote B in here, so I wrote B, B is right there. Okay, then I wrote C in the second row, so C is a matrix of zeros, this is D. So this basically I call it a result array, let's suppose. So as you can see in the code as well, so here we had 4 matrices and I want to block them together. Basically I want the first 2 matrices to be A and B, and then in the last 2 to be C and D. So there is this block as well. So you can just write np.block and write the matrices that you want to basically join together. This is one joining method, how to join these matrices. Then we have other joining routines or joining methods as well. First is called a V stack, vertical stack. Then we have horizontal stack. Okay. So for example, if you want to vertically stack them, by vertical stack I mean I want to put one on top of other like this. This is the vertical stack. Horizontal stack means I want to create a horizontal stack of numbers like this. Okay. So I will have A, B, C, D. So let's go to the coding window and check this. I think. Okay. So I have created this matrix and I want to print this vertical stack and horizontal stack. Print vertical stack. So A is not defined. I just have to run this cell, and then I want to run this cell now. So you can see that I vertically stack them. First this is A matrix, then we have B, then we have C, and then we have D. I put basically one on top of other. That's called vertical stacking. Sometimes you want to create a stack of these arrays. So अगर तुम्हारे पास 2 data files है, so what you want to do, you want to create a bigger matrix out of these. So just let me show it on the screen first. So you have a matrix like this. You have some matrix A is a data file, and then you have in the data file with the matrix it's B. And what you want to do, you want to stack them together, but one on top of one another. So you will create a bigger matrix in which the first matrix is A and then the lower part is B. So you can use this method of V stack, vertical stacking. In the vertical stack, arguments will be A, B, C, D, how many our matrices that you want to put on top of each other. So then we have something as horizontal stacking. Horizontal stacking means that you will first have A matrix, followed by B matrix, followed by C matrix, then a D matrix. So this is horizontal and this is vertical stacking. So just going back to the coding window, and I want to print horizontal stack. Let's just call this. As you can see that the first 1 1 1 1, this is the matrix A, then we have matrix B, then we have matrix C, and then we have matrix D. So these are 3 methods. The first thing is we saw the first method we saw that how to create a NumPy array by using existing sequence like lists, tuples. Then we saw there are some intrinsic methods of NumPy like np0s, np1s, or things like that. So then we saw how if we have some pre-existing matrices, like we had some, we want to mutate them and we want to join them together, then there are methods like that as well. Then the other thing is you can even read arrays from the disks. So if you have a disk, if you have some data within the disk and you want to read as NumPy array, so for that we have different packages. For example, H5py is it's basically a binary format. So it's a really popular format for storing large numerical data sets. If you have a large data set, so there is a format called as HDF5 format. So for that we have a different module by which you can just read them, and that will be read as NumPy array. Okay, so we have another as fits. Fits is another format in which you store the data set. That's called flexible image transport system. You don't need to even see that. So there is stropy.io import fits. You can just read some data by using that. Okay, so if you just use these two modules, stropy.io and h5py, these two modules, they'll read these things at NumPy arrays. So I haven't actually created any data file yet that contains some numerical values on my computer. Otherwise, I'll just show you. Just have this in mind. There are ways by which we can read the data by using these different modules from the disk itself. Okay. Then there are other ways as well by which you can create the arrays from the raw bytes. But for that we use strings and buffers. Okay, and here you can have the C or C++ interface. We don't need to go into detail because I don't think you will be using the first methods, but still I have just for the completion purpose I have included them as well. Okay, so last method is that we have special libraries like SciPy, pandas that we are going to cover in the other sessions. By using those, we can also create NumPy array. So we saw the 6 methods, but the most important method I'll say the first that you'll be using, because if you have a list and you want to create an NumPy array, then you saw some functions by which you can create. I think first two, they are really important because most of the times you'll be using, I'll say 99% of the times you'll be only using first two methods. And sometimes maybe you will 1% of the times you'll be reading some data from the file and then you'll be converting it to NumPy array or read as NumPy array. So but just keep focus on the first two methods. In the first method you are using a list or a tuple, the basically existing sequence, to create an NumPy array. In the second you have some functions like np.zeros, np.empty is also there. Then you have some random np.rand functions are also there. So just keep them in mind. So the important is how to create random functions, how to create these random numbers, and other functions are like np.zeros, np.ones, and things like that. So you must know these things, because when you will be doing some analysis on data and then you'll be writing an algorithm, you'll frequently see that you need to create matrices. For you need to create an identity matrix. Let me just give a simple example. If you want to find an inverse of any matrix, so for that you must know, as you know, that A inverse is equal to identity. So you must create an identity matrix and then some matrix. If you want to find inverse of A, then you have to go through the procedure from here and with the identity as well to find the inverse. So for that you have to first create this identity matrix. So this thing is really important. Just keep in mind that you need to remember one thing. The first thing is how to create the arrays by using the list or something like tuples and other things. And the other thing is what are the functions by which I can create these NumPy arrays. I don't think others are so important, but you have to focus on these two things. Then we'll go on the indexing of these arrays. We have seen indexing on the list as well. Okay, so we'll also see how to index these arrays, because sometimes you want to create a view, you want to just you have an array, for example 1, 2, 3, 4, something like this. So you have an array like this and you want to create an you want just get this number 2, or you want to have a slice 2, 3, 4. For that we will see how to use indexing. So there are mainly 3 types of indexing: basic indexing, advanced indexing, and file access. So here we'll mostly focus on basic indexing because more than 90% of the times you'll be using this. Okay, so I'll give appropriate pointers to this advanced and field access as well. Okay. As I told you in the list section, for example, if you have an array like this, so this is 1, 2, 3, 4, 5, 6, 7, 8, 9, let's suppose. So here indexing is done like this. So we have a positive index, that is 0, 1, 2, 3, 4, 5, 6, 7, 8. Then we have a negative index. Just engrave this in your mind, because this is used by lists, this is used by tuples, this is now used by these NumPy arrays as well. So we have -1, -2, -3, -4, -5, -6, -7, -8, and -9. The simplest type of indexing that you can do is you can just call x of 2. X of 2 means, for example, x of any number here. So this number will be 2 and this will be equal to 3. So this will be pointing to 3. Okay. You can use the negative indexing well. If you write x of -2, so what will happen is, so this number will be picked. So this is equal to 8. Okay. So if I run this line, these lines of code, as you can see that 2 and 8 will be the output. Okay. So now if you want to slice, if you want to get a part of an array, so as you know that we have something called as stop, then we have end, start, end, then we have step size. Okay, I also covered that in the list. Again, for just for the completion purpose, I'll show it here. So here we have 1:4, so it will be 0, 1, 2, 3, and 4. So here you can clearly see that from here 1 to this 3, because 4 is excluded. So 2, 3, 4 will be taken. Just remember that this is just a view, not a copy, because we discussed what is a view and what is a copy. Okay. You can also have, for example, if you have a multi-dimensional array, you have a 2D array here. So 2D array can be thought like this: 0, 1, 2, 3, and 4, 5, 6, 7, 8, and 9. You can see it like this. So this array is basically 2 cross 4, maybe 2 cross 5, because we have 5 columns. So if you just try, if we name this array, so if we index array of 0, so what will happen basically is it will just output this much, because we have not given the second index. As we know that the shape of this is basically, this is of 2D, this is a 2D array, so it has dimensions 2 cross 5. But when I index it with array of 0, it will return whole of this array. So as you can see there, I created this array first. Then if I want to store this x of 0 and result, I want to print the result. So you can see that 0, 1, 2, 3, 4. This is the output, because this returns whole of this array. Is this clear? If you just write the less indexes as we have the dimensions. But if you want to just get the basic elements in 2D array, I will discuss that as well. So you have some rows and some columns. So this is, let's suppose 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 2, 4, 1, 2, 3, something like this. So how the indexing works is 0, 1, 2, 0, 1, 2, 3, and 4. So let's talk about this element. This element here has an index of 1, 2. Okay. So if this is named as array, so if I write array of 1, then 2, so this basically will return me the 7th element. So because it lies in the first row and it lies in the third column, it lies in the second row and third column, if you see. So index here, because we have 0 indexing, so the index of that element will be 1, 2. Okay, you might have seen that in linear algebra as well. So if you have an array of this, so if I want to get an element, for example 0, 2, so what will be 0, 2 over here? So this is the 0th row, and then this is the 0, 1, 2 second element. So 2 will get printed. Okay, you can also index it like this. And it's also crucial to note that you can just skip it if you write x 0 or 2. This is basically equivalent to if you just write x 0, 2, and this is basically faster. This way is faster than this, because this basically copies and creates a view, and then there is a lot of hassle going on. But here it can directly access the memory. So it's better if you index the array like this. That's why I mentioned it. This is less efficient, as it creates a new temporary array. That's why this is less efficient. So if you want more efficiency, you can go with this syntax. So I told you this is something called as syntactic sugar. Huh? Syntactic sugar basically things which can do the same thing but just with some other index, with some other syntax. So here you can see that this is faster and efficient, basically, because it does not create a temporary array. And if you see both of these, x0 it outputs 2, and both of x 0, 2 also outputs 2. Both of these output the same value. Is this clear? Is it clear? I think very less people joined today. I don't know, people are watching recordings. Now let's go with the slicing. Okay, now we saw how to access these elements as well. So there are methods of slicing as well. So we'll see that how can we slice these. We'll directly go to the examples to see, because these are the methods by which you can slice. First thing is you can use the range and valid indices to create the slices. Then you can use array views as well. And then I have written these notes, and you can just check over here. If I have an array like this, so here I think we discussed this. This is start, then we have an end, then we have a step size. Okay. So if I create 1 to 7 and step size of 2, I hope that you will be able to do it. Okay, just let me go to the coding window and ask you a few questions, maybe just so that you don't sleep. Why is this slice important? You will see like how much this slicing is important when we'll go to the real projects and things like that. What if I write 2 and then I'll go till 8 and I'll have a step size of 3? Can you do it? What should be the output? Can you tell me the output of this? What should be the output of this? See it again, like 2, 8, then 3. Are there some other answers? So I'll just create a new set. Only 5, and Sharika is saying 2, 5. So let's print the result and see, and then we'll evaluate who is right. Print a result. Umar, do you have an answer? Let's see what's the answer. So answer here is 2, 5. So let's see why is the answer like this. Okay, so let's go back here. So you can see that we had 0, 1, 2. Just index, we'll index it. So this is 0 index, 1, 2, 3, 4, 5, 6, 7, 8, 9 index. So the question was 2 is to 8 is to 3. The step size was 3. The first element we'll take is this. So the first thing is 2 will be there. And then we'll have a step size of 3. 1, 2 and 3. Now we'll take 5 as well. Okay. Then we want to take again step size of 3. 1, 2 and 3. But 8 is excluded here. That's why the answer should be 2 and 5. 2, 5. Okay, just one more example so that it gets ingrained in your brain. What if I write, let's suppose 2, 9, and I'll write 4 over here. So what should be the output? So what should be the output of this? Two, 6. Umar, what should be the answer? I think we have also covered this in the list concept. So if you just remember, let me again tell you this. So we have a start, we have an end, then we have step size. That's why you must give your best, because this also has been discussed in the lists as well. I think very few students are putting their best efforts. Not even best, I won't say the best, but still they are at least listening to the lectures. Okay, if I just run this, you can clearly see the answer should be 2 and 6. Let me just go through it. And you can see the answer is 2, 6. Let's go back and see what are the other methods of slicing. The other method of slicing here is we can use negative indices. Okay, so I told you that negative index starts from the backwards. So this is -1, -2 and things like that. So this is, so if I will say x -2 is to 10, so it will happen from -2 and it will go backwards. Okay, so let me give you this to you as a maybe problem, and we'll just go this towards this coding window. So what should be the answer to -2? And let's suppose not even 10. Let's write 10. So what should be the answer of this? So what should be the answer? Or will there be an answer? The answer is 8, 9. Why is it? Can you explain? Can somebody explain why is the answer 8, 9? So do you see that? Do you even go to this index 10? What if I write 11 over here? What if I write 11? So what will be the output? So if you can check, it is still 8 and 9. Why? What if I write 8, 2 and maybe I write 5? I hope that now it's visible. So I'm writing -2 is to 5. So it is not giving any answer, as you can see it here. But when I wrote minus 2, and then I wrote, let's say I wrote 9. So you can check the result over here is only 8. Let me explain this concept. This is very crucial. You have to understand this. That's why I include this example as well. Okay, just keep your attention here for a few minutes, and you'll be able to understand this concept. So what is here is this x minus 2 and then is 2. This basically will start from minus 2 because the negative index is here. Are you able to see the screen though? Yes, I think you are able to see it. So we have minus 1, minus 2. Okay, so this is negative indexing. Then we have positive indexing 0, 1, 2, 3, 4, 5, 6, 7, 8. So if I write minus 2, so it will go here. Okay, but as we know that if we do not write any step size, then by default step size is 1 by default if you see it. Okay, then there is a case, for example, what will happen now is I am writing minus 2. Then what I am doing is I am writing plus, let's suppose 9 over here. Okay, plus 9 means till this point. Okay, but this 9 won't be included in this. So what will happen? Only 8 will get printed. But if I wrote 10 over here, so what is the meaning of 10? 10 means go out of the array, include this 9 as well. So the answer will be 8, comma 9. Is this clear? So for example, I can mix up these negative and positive indices. So you have to see. But if I write 5, okay, now this minus 2 and 5, it does not make sense. So it'll write an empty array. Okay, because it wants to take, minus 2 tells it to take the elements from here, for example. And then I'm suddenly going at position 5. So it won't take anything. So it will give just an empty array as an output. So if I just write that, you can see if I wrote minus 2, comma 5, so it will be an empty array. Because it cannot go backwards. So here you can see. But what if I write minus, let's suppose 5, and then I write 8. So what is the output now? So you should be able to answer it right. So I wrote a negative index, then a positive index. Minus 5 and 8. So if I run it, so you can clearly see that the answer was 5, 6, 7. So this is how I can mix up these two things. Okay. Again, going back, again asking you few more questions. What if I write, and I'll write here minus 1. So what should be the answer? Can you see the screen? And I wrote minus 5, 8 and minus 1. What should be the output? So it should show error. So what is the answer Umar is saying? Okay, let's run it and see. This again is an empty array. So I'm again making like a confusing statement to it. It won't basically, it is not an error. It is valid syntax, and there is no semantic mistake. So this Rian was sort of correct. It is not an error basically, but it is because we are confusing basically the interpreter. Minus 8, then 8, minus 1. I want to go it reverse. Minus 5, then minus 6, until it'll never reach 8 basically if you see it. So if you see it, I am saying that step size should be minus 1. So it will go minus 5, minus 6, minus 8. It will never reach 8 basically. So it is nonsensical to say. But there is no syntax error if you see. Syntax is perfectly correct. So it did not give an error, but instead of that, it gave an empty array to me. It said like, look, this is an empty array, take it. Okay. So what if I write x is, I write let's suppose 3. I'll write 3 and then I'll write let's suppose minus 6, then I'll write minus 1. So what should be the answer now? Is there some other answers? So the answer is 765. This was the easiest among them because we are going in reverse. We are saying take minus 3, then take minus 4, then take minus 5 until minus 6, but do not include the last index. That's why we got these 765 in the reverse order. Is this clear? Is this much clear? So how do we use these negative indices? Is this clear? Okay, then we can have like default values. I also discussed this. For example, if you write x 5 is to nothing, so this will take an end value over here, so this will print everything after 5 including the 5. If I write x, then I'll write nothing and I'll write some index, let's suppose 7, so it will take 0, it will start it from 0. So this is by this is called, these are called default values. Default value. Sometimes you will write array. So what if I write x like this? So what should be the what should get printed? Let's go to the coding window and see. I am writing x, then what I am doing here is I am just writing this dot. So what should be what should get printed on the screen? Okay, because by default the values will be from start to end. So if I just run it, everything should get printed. So this is basically equivalent to printing x. But what if I write 7 over here? So what will get printed? Zero to 6 or 0 to 7, because here the indexing itself starts as 0, but and we have an element 0 as well. So the answer should be 0 to 6 or 7. So what should be the answer? 0 to 6 is correct answer because we do not take last index. Okay. So here we have 0 to 6 because this is excluded, this 7 is excluded. Okay. So I hope that this concept is clear as well. Okay. Then there are other methods of slicing as well. I hope that they are a little bit of advanced methods. I think these are easy to grasp. So I don't need to discuss these things. For example, there is something called ellipses. So please read these notes because I don't want to go through every method of these. I want to also give you some home. For example, look at these ellipses. So these are not difficult to grasp. So the only thing you know, you must know what is slicing. Slicing basically taking a part and portion of an array basically. So there are some other methods as well. So let's move to the data types that NumPy offers. So NumPy offers a lot of data types. For example, we have bool data type, byte, ubyte, short. So we also discussed like while defining these np.array, you can put d type in there. So this is a list of data types that NumPy offers. So if you can see on the screen, so it's a huge list. Okay. So this list you can go through. So you must know that there are these data types that are there in NumPy. So all of these you can just go through them and you need not to memorize them. I'm not saying, I'm continuously saying you not to memorize these things. Why? Because you know that there are different data types, you just have to look them up. That's why I'm just covering these things for the completion's sake, so that you should know that there are data types. और तुम्हें जैसे तुम लोगों को ढूंढने होंगे ये चीज़, so you'll just Google it. It's just one Google search away. So these are data types in that NumPy supports. Then this is the most important thing, most important. Till now we haven't discussed what NumPy can do. Now we'll see NumPy things in action. Okay. So this is the most important thing. If till now you have not given your attention fully, but I urge you to give your full attention, because these are the operations we'll be using more than 80% of the times while dealing with NumPy. Okay. So these are called as linear algebra operations. Okay. So what are these operations? For example, if you want to add two matrices, if you want to multiply matrices together, there are operations that the NumPy has defined. So for that, we'll use these linear algebraic operations that have been defined in NumPy. So if somebody tells you why are they fast, because they basically use the C, and there's something function utilized that's called BLAS and LAPACK. So these are the things that are used underneath the NumPy to use these operations. So you need not to remember even these, but just remember that there are some other packages that NumPy uses to build on these things. The first operation is dot operation. Okay, so what is a dot operation? So if you have an array 1, 2, 3, okay, and then if you have another array 4, 5, 6, and you want to multiply these things together, and then you want to add them. I basically want to create 1 multiplied by 4, then plus 2 multiplied by 5, plus 3 multiplied by 6. This operation is called dot operation. Okay, so there is a method in NumPy that is dot. So what it does is, if I create two arrays, NumPy and an array A and array B. So if I write NumPy dot A and B, so what will happen is it will basically perform this operation. That's what this operation is called, dot operation. Okay, so here you can see it first multiplied these two things together, then multiplied these two things together, then multiplied these two things together, then added them together. So this is the dot operation. So if I just 1 multiply 4 is 4 plus 2 10 plus 3 6 18. So 28 plus 4 is 32. So 32 is the answer that is printed on the screen. So this is called the dot operation. Okay. Now what if you want to create this dot operation and you want to perform this dot operation within multiple arrays. So you have an array A, B, C, or suppose D. So you have 4 arrays, and they have values in them. Okay, and you want to basically multiply each element together and then want to sum their things. So why is this dot operation very important? Because when you will perform some machine learning algorithm, you will see that we are using 2 arrays and then we are performing a dot operation of these to get some result. So you must know that dot operation. If you have just 2 arrays, you can use this np dot. Then if you have multiple arrays for which you want to create a dot, you want to basically create a dot product of these things. So what you have a function that's called multi-dot. Okay, so that's why np dot linear algebra, linalg means linear algebra. This is a submodule of NumPy array. So you can just have this function and give this as an argument. Okay, then you can create the dot product, basically a multiple dot products. Okay, so here you can see that first we'll have, so you can just try out these things and then see in the code. I'll give these as PDFs, and then you need to test them so as to see what are the functionalities. Then we have vertical dot operations. If we just have 2 vectors, for that we have v dot. Okay, there are all of these functions. Then there is something called inner product. It basically is a dot product. Okay, it similarly works in dot product, but inner product, it works with multiple arrays as well. So if you have one array and if you have a second array, it works with multiple arrays as well. So then we have an outer product. Outer product is different from inner product in a way. If you want to multiply 1 and 2. Okay, dot product means, inner product means you will multiply this and this, this and this, and add them together. So here what you will do is you will create an outer product. So outer product will be like this. So 1 comma 2 will be written like this, and then 3 comma 4 will be written like this. Then we will perform a matrix multiplication here. So here, as this matrix, this is 2 cross 1 and this is 1 cross 2. So here we will get a full-fledged matrix. We will get 2 cross 2 matrix. So in the dot product or inner product, we get just a scalar, a number. Okay, but with this outer product, we get a full-fledged matrix. So if I, instead of this, if I write, let's suppose I have a vector 1, 2, 3, 4. And if I multiply it with 6, 7, 1, 4, something like this. So when I'll do its outer product, so outer product will be just multiply 1 with 6 and write 6 over here. Okay, then write 1 7, write 7 over here, then 1 4, things like this, and then similarly like this, and this will be a 4 cross 4 matrix. So if I write inner product of this, inner product will be multiply these two things together, 1 multiplied by 6, then write and add 2 multiplied by 7, 14, then add, and it will be a scalar. So inner product, these are basically most of the 2 important things that you have to sort of learn. Because sometimes I'll tell you we'll compute inner product of these 2 things, because we'll have some data in an array, and then I'll say I'll compute inner product. So you must know the inner product gives scalar as an answer. Scalar value. Scalar value means just one value. And outer product, let's just rub this. Outer product, it gives a 2D matrix. Okay. Let's go to the coding window to make it clear. So here I'll just go on these. So there is a function dot outer. So if I want to create 1 comma 2 comma 4, let's suppose, and 1 comma 3 comma 4 comma, let's suppose 2. So let's first see inner. So what should be the answer? Can you compute it by head? What should be the answer of this? So this is the inner product. The answer should be just a scalar. So can somebody calculate it and give me the answer? Is there some other answer? So if I just run it, so the answer is 21. What if I write outer? So what will happen in outer is, it will perform a matrix multiplication. The first thing is, what should be the answer? Will it be a scalar or will it be a matrix? If it is a matrix, then what should be the size of that matrix? 3 cross 3. So what should be the values in that matrix? What is the first row? I'll ask first row. What's the first row in that matrix? So Umar will tell the first row and Sharika will tell the second row. One, 1, 6 and 15. So what will be the second row? because you have to know these operations, because you have to do a lot of maths and machine learning. That time you must know how to do these outer product and inner product. Sharika, are you there? So have you understood the outer what is the meaning of outer product? Okay, let me again go through it and we'll see what will be the. I have to write outer, sorry, I just ran it. I wrote out. So let us go back to this screen. For example, if I have a vector like this, 1, 2, 3, and 4, and then I have another vector 2, 4, 6, 7, something like this. Let's call this A, let's call this B. So if I will write inner product basically means multiply each of the elements together and sum them up. So inner product gives the answer as a scalar, and outer product gives the answer as a matrix. Okay, so inner product answer here will be 1 multiplied by 2 is 2, plus 2 multiplied by 4 is 8, then 3 multiplied by 6 is 18, then 4 multiplied by 7 is 28, and then sum them together. So 28, so 18 plus 8 is 26, plus 28, so this is 53, 54, 54 plus 2 is 56. So the answer will be 56 as scalar if I just call the inner product on this. So what is the outer product here is, so it will create a full-fledged matrix. So first the whole of this row will get multiplied by 1. So 2, 4, 6, 7 will be as it is. Okay, then this whole row will get multiplied by 2. So 2 multiplied by 2 is 4, 8, 12, and 14. Then this whole row will get multiplied by this 3. So this will be 6, 12, 18, 21. Then whole of this row will get multiplied by 4, and accordingly will get the result. This is called the outer product. So the question in hand we had is, we had 1, 2, 5. 1, 2, 5 is one, I'll say matrix, or I'll say array, and then we have another array is 3, 4, 2. I wanted you to calculate the answer. So this is A and this is B. I want you to calculate A comma B outer product of these things. So what should be the answer? Now give me the whole matrix row wise. Sharika, have you understood the outer product first? Right. Nice. So this will be the outer product. Inner product means you just have to multiply these two things together, then these two things together, then these two, and add them up. 3 ones are 3 plus, 3 twos are 4 twos are 8 plus, 5 twos are 10 plus. So this is equal to 18, 21. So this is the inner product. So inner product means just take elements of one, let's say suppose array, and multiply it with the corresponding element, and then add it with the second element of each and third element of the each things. So I hope this is clear now. So what if I wrote here, I wrote outer of AB. What if I wrote inner of A comma B and inner of B comma A? Okay, so I'll go on this screen. So here I'll just write inner. Just I am changing the order basically. So I am changing the order here. I am writing this result 1 and result 2. So I am printing result 1 and result 2. So what should be the answer of this? So what should be 3 plus 8 plus 10 is equal to 3 plus 8 plus 10 is 21. So 21 should be the answer for both of these. Okay. So what if I write outer instead of these? So I'll write outer. Okay, I will compute outer product. So here now I'll do BA, sorry. In the inner as well, if I write BA, now I'm changing the order AB, BA. So what should be the answer in both the cases? Umar? If Riyan is there, Zubair. So what should be the answer in the first case and what should be the answer in the second case? Okay, let's see it. So is everybody in agreement with Sharika? Yes. So you can see here that the answers are different in outer product. So this means outer product is not commutative. So there is some property called as commutative. Just keep this in mind. Inner product is commutative, because if you write A inner B, so it will be B inner A. But if you write outer product of A comma B, it is not equal to outer product of B comma A. Just keep this in mind. So sometimes what will happen is I'll tell you to compute an outer product. So but I also should give you the order of operations. So what should be the first array and what should be the second array. Okay. Then we have the matrix multiplication. I think all of you know how to multiply two matrices. So if I have a matrix 1, 2, 3, 4, this is one matrix. Let's suppose this is A matrix. Then I have B matrix 5, 6, 7, 8. This is in the matrix. So if I want to multiply them together, you know that matrix multiplication has a unique way. So what we'll do is we'll first take these two and perform dot product of these two. So 1 multiplied by 5 plus 2 multiplied by 7. 14 plus 5 is 19. So first entry will be 19. Then again take this and take this thing. So 1 multiplied by 6 is 6. 2 multiplied by 8 is 16. 16 plus 6 is 22. And similarly we'll fill other things here. So I think you should also do this with for loops. So I'll have a question on multiply two matrices by using the for loops. But here you have just one line of code, matrix mul, mat mul, and you will just give A and B. Again, we know that A multiplied by B is not equal to B multiplied by A. In matrix multiplication basically is not commutative again. Okay, then we have tensor dot product. Tensor means basically an array which is greater than 3. So here this will also perform the matrix multiplication, but here the array can be 3-dimensional arrays, 4-dimensional arrays. Okay. Then we have power operation. By power operation I mean if I have a matrix 1, 2, 3, 4 and I want to raise every element by the power 3, let's suppose, or I want to for example cube this. So by cubing I mean I want A multiplied by A multiplied by A. One power is that I will raise every element to the power. This is not that thing. This is basically matrix multiplication. I want to compute A square, A cube, A to the 5. This is basically 5 times multiply A with itself. So we have some that's called matrix power. That means A multiplied by 3. That's compute A cube. Okay. Then we have something called as Kronecker product. So what is that? If I have two things, 1, comma 2. So I have an array 1, comma 2. So I have an array 3, comma 4. So what is Kronecker's product is, it will take this first element, it will multiply these two things together. So it will say 1 multiplied by 3 is 3, then comma, 1 multiplied by 4 is 4, then 2, 3, then it will be 6, then 2, 4, it will be 8. Is this clear? What is Kronecker's product? This is also used in quantum physics. So because I am working in quantum machine learning and we use this product a lot. Is this clear how it works? Okay, let me give you an example. So what should be the output if I go to the coding window and tell you, let's suppose Kronecker's product of 1, 2, let's suppose 4 and 3, comma 4. What should be the answer? 1, 2, 4, 3, 4. I have written it like this. So what should be the answer? Quick. Umar, are you there? 3, 4, 6, 8, 12, 14. Let's check it. Okay. Let's check it. Let's just run the cell. As clearly you can see that here. I hope this product is also clear. So I am not urging you to memorize these functions. I am just urging you to keep this in mind that there are functions like that. Because when we'll be going to read algorithms and to code some new stuff, there you will see, okay, I need to multiply a certain element in this way. So in that scenario, you must know that there are functions available in NumPy which does this. Am I clear with this? Do not memorize the name of these functions because they are just one click away. I just want you to know that these things exist there. Then we have something called as transpose of matrix. All of you know that transpose of matrix is if I have a matrix 1, 2, 3, 4. So if this is matrix A, if I want to compute A transpose, I basically want to change rows into columns and columns into rows. So this row is 1, 2, I'll write it as a column. This 3, 4, I'll just write it as a column. So if I want to perform transpose of this operation, you have a function known as transpose. Okay, or in short, you can just write A dot T. A dot T is also this is the shorthand of this. Is that clear? Okay. Sorry. So I hope now it's visible. So what I'm saying is, if you have a transpose, if you have a matrix A, let me write it again. If I have a matrix A and A is 1 2 3 4. The operation transpose means that convert rows into columns and columns into rows. So we have A transpose, it will be equal to 1 2 3 4. So here I have just taken these columns and made them as rows. So there is a function I can write np dot transpose of some matrix A. But in short, you can also write matrix name dot t. This is equal. These things are equivalent. So I even mentioned here A dot t and this np dot transpose of A is equivalent. Is this clear? Is the transpose of matrix clear? Okay. Then you can also perform arithmetic operations on the arrays. By arithmetic operations, I mean you can add them together, you can subtract them together. For example, if I have an array 1 2 3 and the array 4 5 6 and I want to add these things element wise, I want to add 1 plus 4, 2 plus 5, 3 plus 6, something like this, I can just perform this addition. So the answer will be 5 7 9. Similarly with the subtraction, it will be minus 3 minus 3 minus 3, things like that. If I want to multiply these together, so I can create formula 4. So you can just use multiplication, subtraction, division and some things like that. There are exponentiation as well. Okay. So these are the arithmetic operations you can directly create with this. You need not to create for loops and things. I told you that there is something called as vectorization. By vectorization, I mean that you don't need to write for loop. You can just read array 1 multiplied by array 2. So what will happen is it will take each of the element and multiply them together. So in this case, I had 1 2 3 4 5 6. If I just write this, so what will happen is it will output another array 4 10 and 18. But if you want to go the traditional way, you have to write a for loop and you have to write for I in range of something and then write array of I multiplied by array 1 of I and array 2 of I, and then maybe assign it to some C array of I, something like that. So here this concept is known as vectorization. Vectorization means you do not write explicit loops. You just wrote this operation star and NumPy took care of everything afterwards. So did you understand vectorization as well? So I told you NumPy is fast because of vectorization. So vectorization means you don't have to write explicit loops. You can just write the multiplication and NumPy will take care of everything. And then we'll also go in the broadcasting as well. So these are the arithmetic operations that you can use on NumPy arrays. So this can also be done with the 2D arrays as well. It's not only that you can do it on 1D arrays, you can do it on 2D arrays. So I have just given the example of 1D arrays, but you can do the similar thing on these arrays as well. The logical operations are also valid, and relational operators are, for example, if we take relational operators, this greater than symbol. So it will compare it element wise. Is 1 greater than 2? So it will say false. So is 2 greater than 2? It will again say false. Is 3 greater than 2? It will say true. So for this operation, the answer will be this. So it will again compare the arrays element wise. Okay, if you just reuse these symbols, greater than, less than, equal to, not equal to. So what it will do? It will just take the elements and, for example, this is here first element, the second and third element. It will compare element wise and give the array as an output. Okay, so here again you don't need to write for loops. So that's why it's fast. This is also called vectorization. So vectorization basically means explicitly you are not writing any loops, but the comparison is happening or any operation is happening element wise. Okay. So then you can also have trigonometric functions like sine, cosine. So for example, if you want to compute some values of, let's suppose we have this 0 np dot pi by 4, this is pi by 4, this is pi by 2, and for these values I want to see what is the sine of 0. I want to see what is the sine of pi by 4. I want to see what is the sine of pi by 2. So you can just call np dot sine of x, means it will take whole of these things and compute the sine on these things. Let's just go to the coding window and see it in action. I think it's here. So by this I am creating pi by 4 value, np dot pi by 4, np dot pi by 2. These values are created like this. And now if I want have the sine values of all of these, so I can just say np dot sine of x. I'll give whole the array and I want to print this x. So it'll compute the sine of all these values. So if you see here, so it computes the value sine of these. As you know, the sine of 0 is 0, and we also know that sine of pi, or let's say pi by 2, that's equal to this. If you can see over here. Okay. I think I should not. I should print the sine value. Sorry. So we know the sine of pi by 2 is 1, so that's why 1 got printed. So you can also compute cosine values. You can also compute tan values. You have cos h function. These are all trigonometric functions. So you must know that NumPy also supports trigonometric functions. So if you have an array and you want to compute sine of something, cos of something, so for that NumPy uses functions like that, sine, cos, tan, and even some other things as well. Now again, if you want to create an exponent, you want to create exponentiation means e to the power 1, e to the power 2, something like this, e to the power 5. This is called exponentiation operation, exponential operation basically. Exponentiation means this power operation. So if I want to compute, let's suppose I have an array 2, 4, or 5, and I want to compute what is e to the power 2, e to the power 4, e to the power 5. So e basically has a value 2.71. This is called Euler's number. So these are mathematical things. All of I assume that you at least have some exposure to these things. But when we'll be discussing these things in mathematics, and there we'll go into the depth. But that time I won't tell you like I am just calling np.exp. You must know that this is exponential operation. And that time maybe I'll explain you what exponentiation does. But you must know that there are functions like that. There are logarithmic functions as well. There is a log based, and this is called natural log. Okay, there are functions like that as well. Then if you want to compute some square root, absolute values, floor, round, there are functions also. So do you know square root? You know that square root, for example, of 4 is 2. Absolute value basically means if I have absolute value of minus 4, it will be 4. Absolute value basically gives positive values. Okay, floor, I have told you what is the meaning of floor and seal, I think in some session. Floor means if I have 1.2 of floor means take the lowest integer, that's 1. If I have 1.9 floor, it will just take 1. If I have 1.2 seal, it will take 2. The greater number basically. So we have functions of floor as well. So we have functions of round it to nearest integer. For example, this is 1.2, the nearest integer is 1. 2.8, nearest integer is 3. So 3.5, nearest integer is 4. So you can also have functions of round, floor, absolute value, square root, and things like that in NumPy. Are these functions clear? Are these functions clear? I think only 2 students are active and rest will rely on the recordings. Then we have something called as statistical functions. If you want to compute average of things, which is usually called as mean. So if I want to compute mean of these, what is the average? Average basically means sum of all elements divided by number of elements. So if you want to compute the average of these things, you can just call np.mean of this data. So it will output as 3.0. Then we have something called a standard deviation. Standard deviation, we'll look in statics. So it basically, the formula basically is take the value and take minus the average value and basically square it up. Then take divide by number of points. This basically is called this is called variance, and take the square root of this is called standard deviation. So we'll see why is this so important, because when you will write error functions, you must know standard deviation. I'll handle these things separately. Just do not, right now you do not focus on what standard deviation is, just focus on there are functions which can compute standard deviation. Okay, then we have a median. By median I mean sort the list together. If I have, for example, 1, 6, 8, 9, 2, 3, and I want to find median of this. Median means sort all of these things. Sorting means 1, 2, 3, 6, 8, 9. Then take the middle value. So middle value, here we have 2 middle values, 3 and 6. If we had a middle value, just take that. But if we have 2 middle values, in this case we have 3 and 6, let's take the average of these things. Okay, that's the median. Then we have percentile. We'll also discuss what percentile is. So we'll discuss all of these things when we'll be dealing with statistics. So these are some statistical values which we must know how to compute. So we can compute them manually, but NumPy also provides functions for these. Just remember that there are functions like mean, standard deviation, median, percentile. We'll go into detail of these things. What is the meaning of percentile? What is the meaning of median, standard, and everything. Okay, so but you must know that there are functions in NumPy which can compute this in just one line. You need not write loops and stuff like that. Then you have summation. For example, if you want to sum all of the elements in here, okay, you want to add 1 plus 2 plus 3 plus 4, you can just, the array basically is 1, 2, 3 and 4. If you want to sum all the elements, you can just write np sum array. So there you will say 1 plus 2 plus 3 plus 4. So this is equal to 10. So the output will be 10. But what if you want to sum the elements in vertical order? So this basically means x is 0. So you will write np dot sum, then you will give array, this as input, by this is array, and then you will say x is equal to 0. So it will sum up these things. 1 plus 3 is 4 and 2 plus 4 is 6. That's why the answer is 2. But if you want to sum the elements in x is 1, so then you can write x is 1 in here. So in an array, I told you that this is called x is 0 and this is called x is 1. So if you just write simple sum, then it will sum up all the elements. If you write sum along the axis 0, it will perform the summation along the 0 axis. And if you write summation along the along axis 1, so it will sum up along the rows. 0 means basically columns, and columns basically it'll sum up these columns, and axis 1 means sum up the rows. Okay. Again, I have told you that there is mean and standard deviation which you can compute. Then we have maximum and minimum as well. For example, if you have an array and you want to compute what is the minimum value, okay, for that you can write min of this. And if you want to see the minimum value around a particular axis, let's go and see the concept of axis so that it becomes clear in your head. Let's take the sum here. So what if I add another column here and I write okay, so what should be the answer for this? If I print sum of rows, that is, I am printing the values along the axis 1. So what should be the answer of this? 1, 2, 3, 4 and 345 is the array that we have, and what we want to do is we want to perform the sum along the axis 1. So what should be the answer, Umar? What should be the answer of this? This is not just sum, this is sum along a particular axis, axis 1. Sharika, are you there? So what is the sum along the axis 1? I explained you the meaning of axis. What is the answer? It should be no. This array basically looks like this. If you see it like it is like this. Okay. So now we are summing up this, and we want to check. And I think you are right. So the sum, it should do the row wise sum. I think we have done some silly mistake somewhere. Yes, here I have to put one more brace. So here you can see that 3748. What if I write axis of 0 over here? So what will be the answer, Umar? Axis 0 means basically sum of these columns 7 and 51. So this is the answer. Okay, I hope this is clear as well. So I'll go to the maximum and minimum. So if I have the same array 1, 2, 3, 4, if I will just call max of these numbers, so it will just return 4 if I only call max. But what if I call max with some axis? If I say axis 0, so it will give 3, because here it will give 3 and then it will give 4. It will give an array 3, 4. Okay. What if I write axis is equal to 1? So it will give 2 and 4. I hope this max and min is also clear. So there are functions as max as min. So the maximum gives the maximum value and min gives the minimum value. Then this is most important. Keep your focus here. There is something called as argmin and argmax. Okay. So what is the meaning of argmin and argmax? So argmin basically means the indices where there was the minimum value. Okay. So it basically returns the index of minimum value. Okay, so argmax also does the same. It returns the index of maximum value. For example, if I have 1, 4, 6, 8, 9, 12, let's suppose this is our array. 12, let's suppose 3. So if I call argmax of this array, let's suppose this is array ARR. So what will happen is, it will not return me this 12, but it will return me the index of this 12. So index here is 0, 1, 2, 3, 4 and 5. The index is 5. Okay. So this is called as argmax and argmin. And sometimes, why are these things important, argmax and argmin? Sometimes you want the value for which a function maximizes. So let's suppose we have a function x square minus 5 is equal to something, let's suppose. And sometimes we want a value for which there is a maximum value for this function. That maximum value is called argmax. Argmax basic definition is that if you have a value on which the function maximizes, on which we get the maximum value for the function, that value is called argmax. Argmin similarly is if we have a function and on a particular value, the function value is minimum. That's called argmin. So you have also argmax and argmin functions in here. So I also told you that I'll be explaining you the concept of broadcasting. So what is the here I explained the concept of broadcasting. So for example, if I have an array like this, so I think this is not purely clear. Let me show it on the screen in here. So what broadcasting means is if you see the second row here, so I have a matrix 0, 0, 0, 10, 10, 10, 20, 20, 20, and if I just add it 0, 1, 2. So what I am saying is just let me go to this screen. I have a matrix like this 0, 1, 2, and then I have 0, 0, 0, 1, 4, 6. If I add 1, 2, 3, okay, so here it will not add only to the first row. What will it do is it will just expand this. So it will make it 1, 2, 3, 1, 2, 3, 1, 2, 3, and then it will add it. So the answer will be 1, 2, 3, 1, 3, 5, and then 2, 6, and 9. So here we just had one row. It expanded that into this matrix and then it sort of expanded it and added it together. This is called broadcasting. Because we had this was just 1 cross 3, but it made it 3 cross 3 according to this. The broadcast means to send something. So here the matrix was of 3 cross 3 size. So it also made this matrix as 3 cross 3 size. Okay. Similarly, if we have things like this, if we want to add, if we have, here it's clear. So here if we have 0, 10, 20 and plus 0, 1, 2. Okay. So what will happen is, so this basically is equivalent to having 0, 10 here along the way. This will just create a 3 cross 3 matrix, and again here it will this is actually 4 cross 3 matrix. It will again compute 4 cross 3 here. So 0, 0, 1, 2 will be appended in this fashion, and 0, 10, 10, 20, 30, and this will be appended in this fashion. So it will add these things together now. Okay, so here 0 plus 0, here it will be 0, 1, 2, then 10, 10, 2, here it will be 11, and then first it will be 10, then 11, then 12. So did you understand the concept of broadcasting? Broadcasting basically means whatever is the size, it adjusts the size accordingly. So to perform some computation, it adjusts the size of other arrays accordingly. So using this broadcasting and vectorization, the NumPy really becomes faster. So they do not use explicit loops. They just make one array similar to some other array and they add them together. Then we can also sort these arrays. Okay, then we have NumPy also creates function called as sort. So if you want to sort these arrays in ascending or descending order, you can accordingly give sort array or sort array, then give this -1 as index. We can also sort multidimensional arrays by using NP sort. Okay, you can also get indices. So these are the functions. There are a lot of functions. I don't want to get into details. I think by this I'll conclude the NumPy array and NumPy library. So I hope that you at least got to know. So what are topics? How to create an array first. What is a NumPy array that you know. Now you know how to create these NumPy arrays. Then you know how to perform different operations on these NumPy arrays. Okay. By these we'll build, because now let me tell you the meat of the course. Why are we using NumPy? So if you have any data, so that data will be represented basically in NumPy arrays. Let's suppose you are analyzing some data which is provided by some medical team or some doctors. So there will be blood sugar level. Let's suppose blood sugar level, then we have cholesterol level, then we'll have heart rate. All of these will be some numerical data types, and we have patient 1, then we have patient 2, we have patient 3, as things like that. Why have we put some at least like 2 sessions understanding NumPy? So let's say for patient 1 blood sugar level was some number, let's say for 220, 242, cholesterol level was 120 and 125, 128. And let's suppose heart rate was 72, 76, 86. So all of this, don't you think that this is an array? This basically is an array. So you will read this data as a NumPy array. You'll read it as a NumPy array, then you will perform certain operations on this. You'll perform certain mathematical operations on this array to compute something. So for example, if you want to see what is the average of average cholesterol level, you can compute. For example, you can just take this row and call np.mean on this row. It will tell you the average. If you want to see what is the maximum, for example, if there's a patient with the maximum heart rate, you can just call np dot, and heart rate will be the array passed to this, and it will give you the maximum heart rate 86. So that's why it's important, because data it represents data is usually represented in numerical values. If you see medical data, most of the columns and most of these values, they basically are numerical values. Here each of the row represents one patient's record, and each of the column represents basically one feature of that patient. So by using, because we have everything basically in more or less is having some numerical value, so we'll convert them into NumPy arrays, and that NumPy array then we can operate them by using the operations that we saw. Again, to summarize, we learned how to create these, what are these arrays, what are these NumPy arrays, then we saw how to create them, then we saw how to index them properly, then we saw what are the certain operations that can be performed on them. There is a lot to do. There are something called as IO operations on this NumPy and stuff like that, but I don't think at this stage this is necessary. So we'll conclude the NumPy here, and I hope that you had at least some understanding, and now you have the context as well. Why do we use NumPy arrays? ये चीज़ें हम लोग use क्यों करते हैं? So because most of the data, I will say nearly 90% data that you will deal in your projects will be of numeric type, and for that you will have to use NumPy. Is the context clear why you use NumPy, and why have you given 2 sessions for the NumPy only? Okay, now what we'll in the next session we'll read about pandas. So in that we'll see how to create such data and how to create such matrices, and then how to read them as NumPy arrays, and even if you have a data file stored in the computer, and then how to read that and what are the powers and NumPy, and then we'll see how to plot it. We'll see what are different plots, what are different graphs. For that we'll see matplotlib is library. Okay, I think I'll try to do these NumPy and these pandas and matplotlib in just one session. Okay, I hope if you have no questions, you got some understanding of this NumPy. If you have questions, I'll just wait for 30 more seconds, then we can close the session. Do you have some questions? Okay, was the NumPy clear? Because this is not rocket science, this is really basic things. Okay, let's leave then. Assalamu alaikum everybody.